Alright, so today we'll be talking about finishing up our chapter on periodic functions, and another example of some pretty easy ones are the reciprocal trig functions, okay? Alright, now, just to point out that these are actually reciprocals, okay, I'm going to write out what they're equal to. They are actually equal to 1 divided by, the cosecant is equal to 1 divided by the sine of theta. The cotangent is 1 divided by the tangent of theta, and the secant is 1 divided by the cosine of theta. Okay? Alright, so those are those actual ones that they're equal to. So if you're graphing on a TI calculator, you will actually need to graph with these. Okay, if you are graphing on Desmos, which I hope everyone is by now, you'll be using these as your actual functions. Don't use, the actual names and stuff. Cosecant, I should probably write off to the side what they are. Cosecant would be CSC, cotangent would be COT, and secant would be SEC. Okay, all right, let's go look at them on a graph. Alright, so here's some really cool things about looking at these ones. I'm going to graph their reciprocals with them too. So let's start with sine and cosecant. Okay, so sine is our pretty normal graph looking right here. Cosecant, and I'm going to do it in black as well, cosecant is actually going to be almost like, it's like a weird type of parabola off the top and bottoms of the sine waves. So that's kind of cool. Okay. Cosine, going to be pretty typical right here. Secant is actually going to be the same thing. Secant is going to be the reciprocal. It's going to be the parabolas off of the top and bottom of cosine waves. Okay. Now, if you're thinking tangent's going to be pretty easy to say, oh, cotangent must be a reciprocal wave or some kind of parabola. It's not. It's a little bit funky, but it does make a pretty nice picture when you put them both together. Okay, cotangent is this if we flipped upside down the tangent waves and then shifted them over pi halves to the left. Okay, and that's what I just see them as. That's the cool thing about it. All right, now the awesome thing is when you have Desmos like this, you can actually graph all of these pretty easily by just typing them out. And yes, cosecant, secant, and cotangent actually follow the same rules. Okay, let me go ahead and have all these right there. Let's do red. There we go. Okay, all right. And as you can see, they're pretty much going to follow the same rules as what we've dealt with, okay? All right, but the pretty awesome thing is that as you guys are working with this stuff, just remember to graph them. Just think about them as the kind of the different cousins of the actual trig graphs. They're actually really kind of cool how they work that way. All right, and if you think about them in terms of reciprocals, okay, I am decreasing in value, okay, and that means I'm getting quickly positive, okay, and then all of a sudden here I change from going that way to actually a different direction, so it's reciprocated, okay. All right, so remember, when you're decreasing in value, you're actually increasing in x value, because if it's a reciprocal, you're actually moving the denominator up, okay. All right. Okay, now if you remember me talking about working with sine and cosine in the unit circle, and now we're talking about reciprocal functions and finding their exact values, you can actually find their exact values by flipping and finding the reciprocals of these ones. So all of the x coordinates are going to be, if I reciprocate them, are actually going to be secant values, and if I reciprocate the y coordinates, they are going to be cosecant values. Okay, now if you notice on several of them I have zeros. If I reciprocate that, I'm actually going to get undefined, which is totally okay. All right, and on some of them, if I reciprocate it, it's just going to stay as 1 or -1, and that's totally fine too. But on some of these, like for example, this would be 2 over root 3 or -2 over root 3, you would have to rationalize the denominator on it, okay? So it'd become 2 root 3 over 2, or I'm sorry, 2 root 3 over 3, and this would become -2. This would become -2 root 2 over, no, this would just become 2. Yeah, this would just become -root 2, and vice versa as you go along, okay? All right? Okay, so when you are finding values for trig ratios of reciprocals, just reciprocate the ratios. In other words, just flip them, okay? And that's it for dealing with reciprocal trigonometric functions. I will talk to you later.